Hi guys, I hope you're having a wonderful day so far. We are continuing to talk about moles, and remember last time we said a mole is a really big number. It's Avogadro's number, which is 6.022 times 10 to the 23rd. So that one mole has 6.022 times 10 to the 23rd particles, which is a huge number. Last time we talked about analogies like how much is a mole of marshmallows or how much is a mole of hockey pucks or something like that. So I want you to think about water, H2O. So each water molecule is two hydrogen atoms bonded to an oxygen. Let's say I have a mole of water. So I have 6.022 times 10 to the 23rd molecules of water. How much would that be? Would that fit on Earth? Yes, it would. Would that fit in an ocean or in a lake or in a swimming pool or even in a bathtub? The answer is yes. Particles are really small. In fact, I can drink a mole of water. I'm going to go ahead and drink a mole of water right now. That was about a mole of water. Let me show you what it looks like. Here's a mole of water. It's 18 grams, about 18 milliliters. That's because molecules are really tiny, and so you need a huge amount of them to give you a reasonable amount. Now let me show you some other substances that I have. I have a mole of copper right here. Very different, right? I have a mole of sulfur, a mole of iron, a mole of chromium, a mole of salt, NaCl, a mole of zinc, a mole of carbon, and a mole of sucrose, sugar, table sugar, C12H22O11. You can see that all of these are different colors, they're different volumes, they're different masses, they're pretty much different in everything, except for one thing. What is the one thing that is common about all of these? Well, they're all one mole. What does that mean? They all have 6.022 times 10 to the 23rd particles. That's the only thing that is common between them. So it seems like the molar mass of each of these substances is different. What is molar mass? The mass of one mole. So how do we know what is the mass of one mole of all these different substances? Let's take a look at some examples here. A mole of sodium is about 23 grams. A mole of carbon is 12 grams. A mole of helium is 4 grams. Any idea where these numbers are coming from? A mole of water is 18 grams. Let me give you a hint. Take a look at the periodic table. We said a mole of sodium is about 23 grams. A mole of carbon is 12 grams. A mole of helium is 4 grams. So you can see that the mass of one mole is actually the atomic mass. Remember the atomic mass that we talked about way at the beginning of the school year? So the number that's here, this is the atomic mass. So the mass of one atom in AMU, in atomic mass units, which are really tiny units. It is also the mass of one whole mole, but in grams instead of AMU. So lithium, for example, one atom of lithium is almost 7 AMUs. A whole mole of lithium is almost 7 grams. And that's the brilliance of that number, the 6.022 times 10 to the 23rd. You do need a big number to represent a reasonable amount of your substance, as we talked about, but it has to be specifically that number so that you can use the molar mass as the atomic mass. So that's pretty cool. How about molecule? Like how about O2? We said O2 was 32 grams. Well, that's not what this says, right? That's only 16. So where's that coming from? Well, O2 is 2 oxygens. So if each oxygen is 16, you add up 2 oxygens, you get 32. Or how about water, H2O? It's made up of 2 hydrogens plus 1 oxygen. So if you add 2 of these plus 1 of these, you get 18. So that's where that comes from, is from the periodic table. The atomic mass is the mass of one atom in AMU or the mass of one mole in grams. So let's take a look at worksheet 2 together. Oops. There we go. And the molar mass, again, is the mass of 1 mole of a substance, and it's obtained from the atomic mass that's on the periodic table. The units for a molar mass are grams per mole. Okay, so let's try to figure out what the molar mass of these substances are. And have a periodic table handy with you here. We'll do a few of them, and then the rest you can do as homework, and then you can check your answers. So lithium. So lithium is just Li. You look up on the periodic table, and the molar mass is 6.941 grams per mole. Let's look at lithium bromide. Lithium bromide is LiBr. So you add up a lithium and a bromine, so you add the 6.941 grams, and you add the mass of 1 bromine, and you get 86.845 grams per mole. How about let's do K. K looks interesting. Al2SO3 So when I have to do one of these, what I do is I make a list of how many of each of the elements I have. So I have 2 aluminums. I have 3 sulfurs, because remember this distributes. And I have 3 times 3 is 9 oxygens. So I do 2 times 26. Let me grab a periodic table. So aluminum is 26.981 grams per mole. Plus I have 3 sulfurs, each are 32.065 grams per mole. Plus 9 oxygens, each is 15.9994 grams per mole. Now, in terms of rounding, I just want you to be reasonable. It depends on, the numbers that you're given in your problem. Just don't let your molar mass, because you can get it to be a little bit more precise. Don't let it limit your significant figures. But I'd say for something like that, 10th place, 100th place, is probably okay. If you add all these up, you get 294.138 grams per mole. Okay, so far we have learned, I'm going to go ahead and make my pen a tiny bit thicker here. So far we've learned how to go from moles to particles, right? We know that I'm going to write moles are the heart of chemistry, because they really are. We can go from moles to let's go particles, right? And the particles could be atoms, molecules, or formulas like we learned last time. 1 mole is equivalent to 6.022 times 10 to the 23rd particles. Now we also learned that we can go from moles to grams, it says grams, or mass, by using the molar mass from the periodic table. Okay, so let's try this one here. It says, how many grams of calcium chloride are in 12.3 moles of calcium chloride? So first of all, we need to figure out what calcium chloride is. Calcium chloride is ionic. Calcium ion is 2 plus, chloride ion is -1, so it's CaCl2. So the first thing you want to do is write down what you have. So 12.3 moles of CaCl2. We're going to do a conversion factor next. On the bottom here, you want the same units that are here to be there so they cancel. So you want to write moles of CaCl2 on the bottom here. And, oops, I'm sorry. On top here, you want to write the units that you are looking for, as long as you can link between them and between the moles of calcium chloride. So we just learned that we can go from moles of calcium chloride to grams of calcium chloride directly using the molar mass. So I can put grams of CaCl2 here. And 1 mole is equal to the molar mass in grams of calcium chloride. So I add a calcium, which is 40.08 grams, plus 2 of the chlorines, which each are 35.45. I add those up, and I get, for my molar mass, 111.1 grams for every 1 mole. Now, here, this is 3 sig figs. My molar mass, I can write it to however many sig figs I want. I just don't want it to limit my sig figs. So if my number that I'm given is 3 sig figs, then my molar mass needs to be at least 3 sig figs. You can make it more, but at least 3 sig figs. So I chose to round to the hundredths place. That's fine. Knowing that, know that the answers that I have versus the answers that you get might be slightly different depending on the rounding, and that is okay. So as long as it's within like 1 or 2%, we're good. So then to get the answer, you do 12.3 times 111.1 divided by 1, which ends up being 137 grams of CaCl2. My moles cancel. I end up with the grams. And this number is 3 sig figs. This should not limit me, and so the answer should be 3 sig figs. Let's go to number 6 next. So number 6 says, how many moles of potassium chloride are in 2.39 grams of potassium chloride? So I'm going to figure out what potassium chloride is. So this is ionic. Potassium is K+, chloride is Cl-, so potassium chloride is KCl. So I'm going to write down what I have. 2.39 grams of KCl. Do a conversion factor. On the bottom, I'm going to put the same units so that they cancel. So grams of KCl. On top, I will put the units that I'm looking for as long as I can link between them. What am I looking for? I'm looking for moles of KCl. Can I go from grams of KCl to moles of KCl? Yes, I can, using the molar mass. I can link between the grams and the moles of a substance using the molar mass. Okay? 1 mole of KCl, so the 1 always goes with the mole, is equivalent to how many grams of KCl? To figure this out, you add up a potassium and a chlorine together. Potassium is 39.0983. Chlorine is 35.453. Add them all together. And the molar mass is, I'm going to round it to 74.6 grams. Again, use whatever rounding you want. Just make sure it's not less sig figs than this. So this is 3 sig figs, so I should have at least 3 sig figs. My grams cancel. So I get the units that I'm looking for, which is moles. And I do 2.39 times 1 over 74.6, which ends up being 0.0320 moles of KCl. So I want you to notice here, I put moles on top and grams on the bottom so I can cancel my grams and I end up with moles. In the previous problem, I put the grams on top and the moles on the bottom so I can get rid of the moles and get grams. But in both of them, the 1 goes with the mole and then the molar mass goes with the grams. So make sure that you know where to put your numbers and your units. I always put my units first, and then from there I put my numbers in. Let's try number 9 next. So number 9 says, how many grams of potassium chlorate are in 3.66 times 10 to the 25th formula units of potassium chlorate? So potassium chlorate, potassium ion is K+, chlorate ion is ClO3-, so potassium chlorate is KClO3. So let's write down what we have, 3.66 times 10 to the 25th. I'm going to abbreviate this as FUN, formula units of KClO3. I'm going to start my conversion factor on the bottom. I'm going to put the same units as I have so I can get rid of them. And on top, I want to put the units I'm looking for. Let's look at what units we have. We have grams of potassium chlorate. Can I link between formula units, which are particles, and grams right away? I cannot. Let's look at this right here. I am given particles, formula units, and I'm looking for grams. I can't go directly, but I can go through the moles. So this is a two-step problem. I can go from particles, from the formula units, to the moles of the KClO3, and then I can go from the moles of the KClO3 to the grams of the KClO3. So it's a two-step problem. So the first step, I'm going to go from the particles to the moles using Avogadro's number. So I'm going to put moles on top. Like I said, I always go with my units first and then I pick the numbers. So I know that 1 mole of anything is 6.022 times 10 to the 23rd particles. Now this gets rid of my formula units, and now I'm at moles. My units cancel and I get moles. That's not what I wanted. I wanted to go to grams. So now I can go from moles to grams. So now that I have moles, I'm going to put moles on the bottom here so they cancel. And I'm going to put grams of KClO3 here. And to link between moles and grams of the substance, you want to use the molar mass. So we're going to add a potassium, a chlorine, and 3 oxygens. So each potassium is about 39.1, a chlorine is 35.5, each oxygen is about 16.0. Add them all together. The molar mass of KClO3 is 122.6 grams. And now my moles is in 1 mole, I'm sorry. So now my moles cancel, my formula units had canceled, and so now I can get grams. So on your calculator, you want to put 3.66 times 10 to the 25th, divided 6.022 times 10 to the 23 times 122.6. So anything on top you multiply, anything on the bottom you divide. For our sig figs, this is 3 sig figs, this is 4 sig figs. This should not limit you, you should have at least 3 sig figs. And so my answer should be 3 sig figs, and my answer ends up being 7,450 grams of KClO3. Let's try number 12 next. Number 12 says, how many formula units are in 101.2 grams of potassium bromate? And how many oxygen atoms are there? So let's start with how many formula units are in 101.2 grams of potassium bromate. So I'm going to first start by figuring out what my potassium bromate is. So ionic again, you've got to balance out your charges. So KBrO3. I'm going to write down what I have, 101.2 grams of KBrO3. And I'm going to start a conversion factor. On the bottom, I want to put grams of KBrO3. On top, I would like to put formula units. But can I go from grams to formula units directly? No, you cannot. You have to stop by moles. So this time we're given grams. We are looking for formula units, which are particles. I have to pass by the moles first. So it's a two-step problem. I got to go from grams to moles of KBrO3, and then from moles to formula units of KBrO3. So the first step is going to moles. So I have grams. I'm going to go to moles. To link between grams and moles of a substance, you use your molar mass. You put 1 next to the moles, and next to the grams, you add up a potassium, a bromine, and 3 oxygens. If you go ahead and add all these together, you get 167.0. Hopefully you have your calculator and you're working on these together with me. And this gets rid of the grams. Now, that ends up with moles. That's not what we wanted. So we're going to do a next step. The next step, you're going to put moles on the bottom so they cancel. And we're going to put formula units on top, because that's what we're looking for. And remember to go from grams to formula units. 1 mole is equal to 6.022 times 10 to the 23rd formula units or particles. So 1 goes with the mole, 6.022 times 10 to the 23rd goes with my formula units or particles. My moles cancel, my grams had already canceled, and I end up with 3.649 times 10 to the 23rd formula units of KBrO3. And that's my answer. So that's how many formula units there are. Now the second question asks you, how many atoms of oxygen are there? There's different ways to do this. Once you have the formula units, remember you can compare between particles and particles. So once I have this, the easiest way to do this is to say, well, if I have 3.649 times 10 to the 23rd formula units of KBrO3, I can do my conversion factor, put formula units on the bottom, and put atoms of oxygen. And I can link between particles and particles. So I can say one of these formula units has 3 oxygen atoms. So I just multiply by 3. The answer that I get is 1.095 times 10 to the 24th atoms of oxygen. Another way you could have done it is, it's kind of longer, but you could have, after this step right here, once you got to the moles of KBrO3, you can go to moles of oxygen. Remember, you can link between moles and moles. So you can figure out how many moles of oxygen for every mole of KBrO3. There's 3 moles of oxygen. And then you could say, well, for every mole of oxygen, there's 6.022 times 10 to the 23rd atoms of oxygen in 1 mole of oxygen. So there's different ways to do it, but this is probably the easiest way to do it.